Good morning, students. So we'll move on to the fourth question over DFA pattern recognition problem. Remember, whenever we get such kind of pattern representation in our problem, okay, so we are considering it as the questions are belonging to pattern recognition problem. Okay, so in this question, they are mentioning, like, observe it carefully. Obtain a DFA to accept strings of A's and B's starting with the string AB. Okay, so out of entire string, okay, or else whatever may be the number of possible strings we can generate from these two alphabets AB. Okay, so that should be beginning with AB. That's it. Okay, like A should be followed by B. Okay, A should be followed by one B, or else multiple number of B's, does not matter, but it should begin with AB. That's it. Clear? Fine. If you are having like 100 different characters in one particular string, example, okay, out of that, first two should be what? AB. Okay, if it is BA, it should be rejected. Remember, if it is double AB, it should be rejected. Remember. Okay, so now for this example, or for this question, okay, the possible input strings which are accepted are, see, AB, A will be accepted, then AB, B is accepted, then A triple B is accepted, then A B A is also accepted. Okay, so these are all the possible strings which have been accepted by our DFA. Okay, so accepted, which are all rejected exactly. Okay, so double A, if it is there, it will be rejected. Okay, double A B, if it is there, then it will be rejected, or else BBA, if it is, it will be rejected. Then BA, if you are beginning with, then also it will be rejected. So these are the few possible strings what we can decide, okay, before we design the DFA over there. So this idea you should get, okay, when you observe the question, okay, because based on this we can design the DFA or NFA any kind. Okay, clear? Okay, so here minimum string is what? AB exactly. Okay, so the length of the minimum string is equal to what? 2. Is it? Okay, A and B, 2 we are having. So the number of possible states will be equal to what? 3 exactly. N plus 1 will be equal to 3. So let me consider it as Q0 as the first state. Okay, then later Q1 as second state, and later Q2 as third state. Okay, so we'll decide which one will be for start state and which one will be final state over here. Okay, so now I will make Q0 as start. Okay, I will make Q0 as start state. So AB we are having, right? So on receiving A, Q0 should move to Q1 on receiving A exactly. Okay, fine. Then Q1, if it is receiving B, okay, then it should go to Q2 exactly. So if I want to make a string AB to be accepted by this particular DFA, what I need to do? I need to make Q2 as a final state. Is it right? If I make Q2 as a final state, then string beginning with only AB, okay, or else if string is equal to AB, then it will be accepted. This is what the basic condition what we can. Okay, now AB is accepted by this machine. Okay, fine. Then ABB, if you are having, observe it carefully, ABB if you are having, then it should be accepted or rejected. It should be accepted. Why? Because it is beginning with AB. Okay, so for A we have transition from Q0 to Q1. For B we have transition from Q1 to Q2 exactly. Then what about for B? We don't have. Okay, so what we need to do? We need to provide a self loop for Q2 and name it as B. Okay, then ABB will be accepted. Is it right? Then what about ABA? Whether it should be accepted or rejected? Observe it carefully. Whether it should be accepted or rejected? It should be accepted. So AB will be consumed by Q0 and Q1. Okay, we are at the final state now. Okay, then what I need to do? I need to use small a, one more, the last element of this particular string. What is that? A exactly. So if I provide a self loop for A also for Q2, okay, then it will be accepted. So let me write it as B comma A, means Q2 will accept either A or B exactly. So now just observe this. Okay, if a string is beginning with AB and followed by any number of A's or followed by any number of B's or followed by a combination of AB, okay, Likewise, see here, AB, AB, then again AB, okay, whether it should be accepted or rejected, it should be accepted. See, once you are reaching for Q2, okay, means we are, observe it carefully, okay, we are finding AB in the initial part, then only you are going to enter this. Is it right? Okay. Do we have any transition for B over here? No. Okay. Do we have any transition for A over here? No. Okay. Means we are restricting our DFA that if the string is beginning with AB, then only you are reaching this particular position. Clear? Okay. Otherwise, you will be left in Q0 itself. Example, if a string is beginning with B, okay, if it is what this string we got, BA, okay, observe it. If I provide input as BA for this particular DFA, whether it will be proceeded? No, it will not proceed because Q0 is the start state with no transition available for alphabet B exactly. Is it right? See here, we don't have any transition for this. Right, okay. So this is what we can call it like, yes, it is a perfect DFA which can accept all this string which is beginning with AB. Okay, but here, this you can write, no problem. Okay, but here, we may go for a one trap state. Okay, we may go for one trap state. Remember, always whenever we are using the trap state, okay, we are violating that condition. Like minimum string length is equal to 2, so 2 plus 1 will be the number of states. Okay, so without trap state, we can design 2 plus 1 or else n plus 1 number of states over here. Okay, but when we are adding the trap state, okay, we are violating the condition. Okay, n plus 1, okay, condition we are violating over there. Okay, see, for Q2, what is the, okay, fine, forget about the states. Okay, what exactly the alphabet we got in this particular question? A and B exactly. Okay, so for Q2, we are presenting a transition both for A and B. Is it right? Then what about for Q1 and Q0? See, for Q0, we got only transition for A, and for Q1, we got only transition for B exactly. Right? We don't have it available transition for B in Q0 and A in Q1 exactly. So what we can do is, we can design one trap state. Okay, I will call it as 3, okay, or else Q3. Okay, so whenever we get B as a input for Q0, okay, we are entering for the trap state. Okay, from previous question we discussed what is trap state. Trap state is a state from which, okay, we don't have any transition towards the final state. Remember, that is what a trap we call it as. Okay, whatever may be the input, remember, okay, once you are entering for the trap state, then over. Okay, there should not be any way, any possible way to reach the final state. Remember this. Okay, so now Q0 on receiving B. Okay, see, when Q0 will receive B, if this string is not accepted by B, okay, see here, BA, right? Okay, when the string is not accepted by this particular DFA, then we need to move towards the trap state. Okay, then we are not reaching the final state, then obviously it will be rejected. Clear? Okay, previous skeleton what I designed, okay, without this trap state is working properly, but okay, like we need to mention, remember, we need to mention all possible inputs for the in case of transition. Remember this. Okay, because of that, what we are doing over here, Q0 to Q3, we are providing it for B exactly. Okay, so over for Q0, both transitions we got. Okay, for A also and for B also. Then what about for Q1? We got it for B exactly, right? If you are getting like sorry, double AB, if you are getting, observe it, double AB if you are getting, whether it is in a proper format what you are expecting in this question, no, it should be only AB, right? It should begin with AB, but you are beginning with double A, so it should be rejected, right? So when we are finding that first A, you will be traveling from Q0 to Q1, right? Transition we got. Okay, then what about for second A? Actually, it is violating our condition, which is mentioned in our question. So obviously it must be rejected, right? So what we need to do, if I provide a self loop, observe it very careful. If I provide a self loop in both the cases, see, instead of traveling to trap state, if I make it as self loop for Q0 on receiving B, okay, then BA, if you are beginning with, then it will be accepted. Actually, it is wrong. Okay, it should not be accepted. Because of that, we are coming to the trap state over here. Same, if I provide a self loop for Q1 on receiving A, then double AB, if it is there, then it will be accepted. Actually, it is wrong. Okay, that should not happen. So what we need to do, we need to provide a transition of A for Q1, okay, towards Q3. Clear? See here, for Q0, both AB over. For Q1, both AB over. Okay, for Q2, for both AB over. Okay, so once you are entering for this Q3 as a trap state, okay, we don't have any transition which is moving towards the final state. Okay, finally, it will be rejected exactly. Clear? Fine. So this is what the DFA, what we can design it for this particular question. Fine. Okay. Any doubt? Any doubt? Okay. Observe it very careful. It's very simple. Beginning with AB. Okay. Ending with any number of A's and any number of B's. If you are beginning with like other than AB, okay, then you are going to enter it for the trap state exactly. Fine. So then the machine M can be written as what? Q. This is very important. Remember Q, then sigma, then delta, then Q naught, then later final state F exactly. Okay. Then Q will be equal to what? Q will be equal to what? Q naught, comma Q1, comma Q2, comma Q3. Right? Q2, comma Q3. Okay, then what about for Q naught? Q naught is the start, right? Q naught is the start state. Okay, then final state F will be equal to, F is equal to what? Final state Q2, right? Okay, now you need to write the transition for this particular DFA. That will be delta of Q naught on receiving A will be equal to Q1, right? Then delta of Q naught on receiving B will be equal to Q3. Is it right? Q naught on receiving B, we are coming for the Q3 exactly. Then delta of, we'll go for Q1. Q1 on receiving A, we are entering it for Q3, right? Q3, okay? Then delta of Q1 comma B will be equal to Q2, then later okay, later delta of Q2 comma A will be equal to what? Q2 itself. Is it right? Self loop we got. Then delta of Q2 comma B will be equal to Q2 itself. Okay. Then the last delta of Q3 comma A will be equal to Q3 itself. Then delta of Q3 comma, wait a second. So I forgot to mention one transition available over here. See, I forgot to mention transition for A and B for state Q3 exactly. Okay, so sorry, you need to mention the self loop. Okay, over here, A comma B means if any string starting with B, okay, followed by any number of A's and followed by any number of B's, okay, then it will be remaining in Q3 itself. Sorry students, okay, I forgot to mention this. Okay, then B will be equal to Q3 exactly. Okay, so this is what the possible transition what we can find for this particular DFA exactly. Okay, then later if you want to draw the transition table, okay, so okay, if you want to draw the transition table, how it will be. So we are beginning with okay, A, B. Fine. This is for A and this is for B exactly. And here Q naught, then Q1, then Q2, and Q3. Okay. So it is delta of Q naught on receiving A, it will be going for Q1. On receiving B, it will be going for Q3. Q1 on receiving A, it will go for Q3, and on receiving B, it will go for Q2 exactly. Okay, if you want, you can refer the previous slide. Fine. Okay. So Q2 on receiving B. Okay. Q2 on receiving, sorry, Q2 on receiving A. Okay. It will be remaining in Q2 itself. And for B also, it will be remaining in Q2. Self loop it is. Q3 on receiving A, and exactly self loop it is Q3 and Q3. So this is what the complete discussion about problem number 4 exactly. Thank you, students. Okay, in next video, we'll discuss about problem number 5.